light ray, we said, straight line path the light travels. Okay, second one, electromagnetic wave. It's a vibrating electric and magnetic field that propagates from a source. Let me explain what propagate means, because it's a big, scary word, but it's not that bad. Propagate just means comes from a source. Okay, so if something propagates, it comes from somewhere and goes somewhere else. It just means it moves. Like, electromagnetic waves don't stay in a place. They go places. Okay, and I put in parentheses light because electromagnetic waves are called light. Notice I didn't say visible light. Visible light is different. If I just say light, I'm talking about the entire electromagnetic spectrum, which we'll get to in a second. Which, I apologize in advance, got kind of messy. All right, third thing, electromagnetic waves travel at the speed of light. Remember, c is the speed of light, 3 times 10 to the 8th. And then we get to the electromagnetic spectrum. So the electromagnetic spectrum is the range of light waves. They go from low frequency to high frequency, and they go in this order: radio waves, microwaves, infrared light, visible light, which is broken down into red, orange, yellow, green, blue, indigo, violet. Sorry, like I said, it got kind of messy here. Ultraviolet light, X-rays, and gamma rays. Okay, so that's the order that they go in. It goes from low energy to high energy. We'll talk about why frequency goes with energy when we get to the end of this unit. When we talk about the photoelectric effect. But you get this idea of going from low frequency to high frequency, and the colors match that as well. Okay, and then the last two things I talked about were transparent and opaque. So transparent objects allow light to pass through them. Opaque objects do not. I want to be clear. Objects can be opaque to some light and transparent to others. For example, the wall is opaque to visible light, but it's transparent to radio waves. So radio waves can get in here, but visible light can't. Okay? Glass is transparent to visible light, but opaque to ultraviolet light. So ultraviolet light cannot get in the window, but visible light can. That's why you don't get like if you're sitting in front of a window, your arm may get hot from the visible light and from infrared, but you're generally not going to get sunburned if you're sitting in front of a window, because sunburn is generally from ultraviolet light. Okay. So I want to talk about the cause. I'm guessing a lot of you didn't put the cause of these. So what makes things transparent and what makes things opaque? Transparent objects do not vibrate well at the frequency the light is in. Okay? So for example, glass. Glass does not vibrate well at visible light. So when the visible light hits the particles in the glass, they vibrate a little bit, but mostly they just pass the energy on to the next one. Okay? And it passes all the way through to the other side. And when it gets out the other side, now you can see it the exact way it looked. And it's always basically the exact same as it was before. And the reason being, there's very little change in what the energy to the light particle is. There is some, if you have glass that's not particularly even, you may get some distortion, but that'll be because of refraction, which we'll talk about. The light will bend slightly because there's areas that are thicker or thinner than others. For opaque objects, they do vibrate well at that frequency, and so they turn the light into kinetic energy rather than pass it on. So they keep the energy and vibrate a lot instead of giving it to the next particle. Okay, they're selfish. Opaque things are selfish. They keep all the energy to themselves. When we get to refraction, we're going to talk about the speed of light changes. The reason the speed of light changes is because of this cause of transparency. Because the light vibrates in the object a little bit before it's passed on, that takes time. It doesn't happen instantly. It doesn't take very much time, but it takes a little bit of time. So the light actually travels slower because it's getting vibrated past, vibrated past, vibrated past, vibrated past. Okay? and so that takes more time. It's kind of like if I want to get a potato from me to Nathan, I could throw a potato at Nathan, or I could give it to Jefferson, who gives it to Noah, who gives it to Zane, who gives it to Nathan. It would take more time. Like, we could still do it relatively quickly, but it would take longer to do it. Okay. Any questions about light basics? These are just kind of the basic understandings of light that we have. Aiden, put your phone away. Thank you. Okay? So these are basic understandings we have of light and how light works. All right. Anyone need any of this? I'm about to move on. You good? Okay. All right. Let's jump to reflection. Let's jump to reflection. Good. Excellent. All right. So simple definition for reflection is that it bounces off the surface of light. The law of reflection is the angle of incidence equals the angle of reflection. So theta I is angle of incidence, theta R is angle of reflection. And you can see I drew that here. So here's the angle coming in, and here's the angle going out. And those angles are equal to each other. This is something that confuses people. It's the angle between the incident ray and the normal line, not the incident ray and the surface. Okay, it's not this angle, it's this angle. If you're wondering what a normal line is a perpendicular line to the surface. Okay, normal means it's perpendicular to the surface. It's just a math term. So the incident and the reflected light are always equal to that angle between them and the normal line. Okay. The reason that matters is because if the surface tilts or moves, that also tilts or moves the normal line. And if the incident light doesn't change where it comes from, that means the angle will change. Okay. So it's always with the normal line. Okay, then I talked about diffuse reflection. Diffuse reflection is for rough surfaces. The incident angle is not the same for all rays, even though they come from the same location. So even though the light comes from the same location, the incident rays are not the same angle, and the reason is the normals change. Okay, so because the surface is rough, those normal lines are going to change. And so because those normal lines change, you get different angles. Okay. Huh? Where? Angle of incidence. Okay. And then the last thing I wanted to show you was this diagram of how images form in mirrors. Basically, light goes in all directions from the object, but when it hits the mirror, it follows the law of reflection. And if you backtrack those light rays, they backtrack to the exact location where the image would be, which in flat plane mirrors is exactly the same size and distance as what that object would appear from the mirror. So your object and your image will be the same. So for straight flat mirrors, vertical mirrors, it's gonna look the exact same. They're gonna look the same as each other. However, curved mirrors will change this. Curved mirrors will make it larger or smaller. They make it upside down or right side up. They may make it virtual or real. Flat mirrors are always virtual. They're always the same size. But curved mirrors can change that. Okay, any of these that you need to clarify? Okay, I'm going to go on to the next one, but I'm going to leave this up, so if you need to finish up these here, you can do that, and then I'll leave them up there if you're catching up. Last one I'm going to look at is refraction. Okay, refraction is light that bends when changing from one medium to another, and the reason for this is the speed of light changes. Okay, when it goes from one medium to the other. And you're saying to yourself, Mr. B, we said the speed of light never changes. It doesn't, but it does. So the reason the speed of light changes is because of what I talked about earlier. Okay, what I talked about is the light takes time to pass through the substance, because the substance absorbs it, passes it, absorbs it, passes it, absorbs it, passes it. So the light itself doesn't actually change speed. It's the process of passing it on that takes time and changes speed. So it's an average speed. It's not the actual speed the light travels. It's the speed it travels through the substance. And that changes when you change the medium. Okay? Index of refraction. Index of refraction is a measure of how much light slows when it goes from one given medium to the next. And therefore it measures how much it bends. So something that slows down a lot, like going into diamond, bends a lot. That's why diamonds are all sparkly, because they bend the light a lot, and so they bend it kind of all over the place. Okay. It's 1 for a vacuum. So n is value in a vacuum for n is 1. So like through plain air, it's basically 1. It's not exactly 1, but like out in space, it's 1. Okay. Anything is going to be larger than that. You're never going to have an angle. You're never going to have a index of refraction that's less than 1. It will never be less than 1. It's always bigger than 1. Okay, and then lastly we get to Snell's law. We're going to solve Snell's law. Last year you may have talked about it really briefly, but we did not solve anything with it. We are going to solve some stuff with Snell's law this year, because Snell's law allows you to actually figure out the angle that things are at and what angle they'll refract at. And so we'll do some stuff with Snell's law this year. Ni is the index of refraction for the incident medium. Theta I is the index of, or the angle of incidence, just like it was up there in reflection. Nr is the index of refraction for the refracted medium. And theta R is the index of refraction. Like, I know it's index of reflection up there. Like, just all you have to do is be careful. Snell's law has to do with refraction, so we're talking about refraction. And the angle of incidence talks about reflection, so we're talking about reflection. So yes, I know I got 2 theta R's and they mean 2 different things, but I did that because I have faith you guys can figure it out. You guys are smart enough to do it. Okay? All right. Any questions on that stuff there? Reflection or refraction?